Hello, this is Barry, Kilowatt United 3 X-Ray. Today I'm going to give a quick demo of the Rig Expert AA230 Zoom. Rig Expert really did their homework when they built this unit. Fabulous, fabulous unit. One of the best units on the market that I found, and I have, is a SARK 110. When it comes to features, it does it all, and it does it great. I also have a Rig Expert AA600, which is a very good unit, easy to use. To me, the two downsides of the AA600 are, one, it's called OSL calibration for how they cancel out the transmission line, and number two are sampling points. It only uses 80 sampling points. Well, Rig Expert refined this unit to really come out with an excellent, excellent unit. So let's get started. First, what we want to do is, excuse me, I have this hooked to my 40 meter beam. So let's set the frequency. Push the button. We're going to go 7 megahertz. 007,150. And next we want to program the window, how much of a bandwidth we're going to look at. We want to look at 500 kilohertz. So this is plus or minus, excuse me, so you want to set 00250. So it's 250 up and 250 below. So let's take a reading. So here's a 40 meter beam. It's a Cushcraft Shorty 40. Now we're getting jagged lines like that because of the sampling points. We can smoothen that out, but we'll get into that later when I explain that. So right now the lowest SWR is 1.16 at 75. Which is where this is. Now at 7150, if you can see up here, probably not, it's too small. It's 1.57 to 1 SWR. So we can move that up and down the band, as you can see. So at the bottom of the band, it's 1 point, I don't know, I keep saying 7. It's 1.59 to 1 SWR. And when you go up to the top of the band, let's go up here. That's close enough. We won't go to the top. At 7170, it's 1.70 to 1 SWR. Now, we can change that window because it's 10 to 1 up here till you hit a perfect match here. Now, here's the 2 to 1 point, 1.5, 1.2. So that's a zoom in and out feature on that. Just thought I'd show you that one. Now, let's get into one other thing, and then we'll get into what this thing really can do. Let's do an SWR meter. So here you're checking one frequency. That's it. So at 7170, the return loss is 11.5 dB and the SWR is 1.73 to 1. So now we get down the band a little bit. So it's 1.32 to 1. Return loss 17.3 at 7089. So those are just the simple features. And for the average ham that puts a dipole up, hook the coax up, trims it to where they want to operate, and that's it for the day, that's what this will do, and it'll do it nicely. Also, awful expensive unit to purchase to do just that feature and put it away. But some people like toys, like I do. Now we'll get into the meat and potatoes. Now we're going to get into, if you want, you can check Smith chart. Let's sweep that. So there's a Smith chart. I'm not going to teach you how to use a Smith chart. There's tutorials on the internet for that, but that'll plot the Smith chart. Now, that'll give you the resistance and the reactance, a chart. I'm not going to get into that. All parameters. When you do this, now it tells you at a given frequency at 7089, the SWR is bouncing up and down a little bit as it's sampling. It's about 1.32 to 1. The impedance is 65.8 ohms. The return loss is 17.3. You're not feeding it in phase at this frequency. You're 5 degrees out of phase. The resistance is 65.6 ohms. The reactance is plus 1. Almost 2. It's bouncing around a little bit. So that'll tell you exactly if you're going to put this at the feed point and you want to build a matching network, this is how you would this is what you would use, this information, and then you would build your matching network off of that. Let's get out of here. Let's get into setup for right now. So setup is language. Obviously, we're English. You can change the display colors. Orange I found to be the nicest. The battery, they have like a battery saver mode. I don't know if you can hear it. When I hit the buttons, you get a beep. So right now it's loud. You can change the impedance that this is working on. Right now it's set for 50 ohms. If you want, you can change it 75, 100, or 25 ohms. We'll keep it at 50. The units is imperial, or you can use metric. And the bands, what it does for bands is, when you sweep a range, the bottom and the top of the band, it'll all be in blue, and on the edges where it's outside the band will be black. So I don't need that feature. I know where the bands are, so I have it turned off. It's annoying to me. Velocity factor of the coax you're going to be using. Frequency correction. If you check it against the frequency counter and you find it's off, you can bump it up and down a little bit. Now here's the big feature. Sampling points. So right now I have it set on 100. That's a good range. As I said, the AA600 is only 80. So let's say you check 100 kilohertz window. So this takes a sample at every kilohertz, which is obvious, 100 sampling points. You check a 200 kilohertz window. This will take a sample at every 2 kilohertz. And so on. So if you check an off-center fed 80 from 3.5 megahertz up to 54 megahertz at 100 sampling points, it's only going to take a reading at about every 800 kilohertz. So the first sample is in the band, the next sample is out of the band. And this fills in the blanks, and it'll get the lines and all that, but it's not that accurate. So what you want to do is use 500 sampling points. Now you'll have more points, and you'll have a more accurate reading. And I find that to be an excellent feature on here. The only downside is when you use 500 sampling points to take a sweep, it'll take longer. I think it takes about 12 seconds to sweep the whole span when you set it at 500. Now, if you hook this up to a computer, I hope I make it. My battery's going dead up here. I've been really playing with this thing. If you hook this up to a computer, you can tell this to sample up to 10,000 sampling points, which is awesome. But just so you know, for 10,000 sampling points, it takes 20 minutes to sweep. So you're going to be there for a long time. Let's get back. I don't want to let it there. Oh, 100. Okay, I want to stay at 100 because it's just going to take too long. So let's get out of here. Now, one thing is called OSL calibration. And what's neat with that, I'll take this off. Let's say this is 200 feet of coax. And you hook it to the unit, and it's going to end up being hooked up to your antenna. But you want to know what the actual readings are at the antenna, not at the end of the coax, because once you get off resonance and reactance is plus or minus, this becomes a transformer and you don't have an accurate reading. So what you need is called open, short, load calibration. And that's what these are. This is one is open, one is short, and one's 49.9 ohms, as close as you can get to 50. So what we're going to do is a calibration, and we're going to cancel this transmission line out. So let's see what we have to do here. Let's push the button. Press check mark to recalibrate. So we're going to do that. It's prepare an open, short, load to calibrate. Step 1, connect open. So we'll take one of these guys that are open, got to find it, and we're going to hook it to the other end of the coax. Just give me a second here, bear with me. Now remember, if you set those sampling points high, if it takes 20 minutes, if you're using, I'm going to set this going. There we go. If you set this for 10,000, you're going to have to sweep every load. It's going to take you an hour to calibrate this thing because the open takes 20 minutes, the short takes 20 minutes, the load takes 20 minutes, so you just ate up 1 hour to calibrate. So you really don't want to do that unless you want something really accurate. I did it. I did it to my off-center fed. I wanted a highly accurate reading, and I got it. But that was on the AA600. So there's the open. Now it's going to tell me put the short. So we take the open off, put the short on, push the button, we'll get it going. And then the next one is going to be the load. So we did the open, that's the short. And you really want to do this at 500 sampling points for a degree of accuracy. And right now I have this set up for only 500 kilohertz, if you remember. So this is only going to be accurate where I set it. What you really want to do is set this up for 500 sampling points. And if you're going to strictly work HF, I'm going to have to put the other one on here. Okay, we'll take this off. If you're strictly going to work in HF, then what you want to do is set this up to sweep in the calibration from 1.8 to either 30 megahertz or 54 megahertz, if you're going to include 6 meters. So once you go to 2 meters on this and you did your calibration, it's not accurate up there. It's only accurate where you programmed it. So you don't want to do the whole span, because you're not going to check an antenna that goes from 0 up to 230 megahertz. So pick an area where you want to do it. So now we're just about done. Okay, so we're ready to go. We can get out of here. Now, let's do a sweep. So there's your SWR. See where it says calibrate, that's lit? Now you can turn it off. Now you're back to where it was before. So that profile is saved. So you can let it there and say, we'll come back later and use that. So if you did the 10,000 sampling points, you can save it. So now you want to turn it back on. Turn it back on. Let's do a sweep. Now, remember, that's what we're reading. That 50 ohm load, it's not hooked up to anything, so it stays down at the bottom. That's as close as you're going to get. Remember, this is 49.9 ohms, not 50, so you do get a reading. So that's open short load calibration. Now we'll go back and I'll show you something else that's really neat. Let's say you want to build or make a quarter wave stub. So this is about 25 feet. So you can check this. Let's say you made this stub using a noise bridge years ago and now you want to check it. So now what you can go into is tools, if I remember correctly. Tool stub tuner. So now we're going to run this. Connect the cable, open or short far end. Okay. Now it's going to check this cable and it's going to let you know where it's resonant at a quarter wave and at a half wave. I have that turned on. I'm sorry. Let me get rid of that. I got to turn that off. That's no good. That's no good. So sorry. Set up. Oops. Okay. Now let's go back. Sorry about that. Let's get back into tools. There's tools, because it won't see it. It's going to say nothing's there because I canceled it out. Here we go. Now it's going to tell us that this is a quarter wave stub at 6.331 megahertz, or it's a half wave stub at 12.9 megahertz. And there's an open on the far end. It's letting me know. So this will keep going. I won't go through all of that. So now you know what this is. So if you want, you can use this feature and trim it to get it up to 7 megahertz. If you want 7 megahertz or 13 or 14, whatever you want to do, you can start trimming. You can use this feature. It'll keep on sweeping continuous. So now here's another feature. It's called time domain reflectometer. So let's say this is a couple hundred feet of coax going to your tower, and you have a high SWR. All of a sudden it went nuts, and you have squirrels out there. And you found out down the road the squirrel ate through the coax and it opened it up. But you don't know that yet. All you know is that you have a problem. So now what we have to get into is time domain reflectometer. Now I'm going to start that and I'll describe it as we go. Now what it's doing, it's sending a signal out to your antenna. You can leave the other end hooked up. You don't have to disconnect everything. It's sending a signal out to the antenna, and the SWR went high, so you know you have squirrels, and you know that squirrel ate through the transmission line. So now what you want to do is find out where in that transmission line did the squirrel eat through it. So this takes a little bit, and again, you want to run 500 sampling points when you do this for accuracy. But you don't have to. You can run 80 if you want. It'll get you to the general area. My 40-meter beam failed, and I used time domain reflectometer, and I found out about 89 feet out, plus or minus, because I forgot to put in the velocity factor to coax, that there was a short. Well, at the bottom of the tower, I knew there was a set of barrel there was a barrel connector and PL259s. So I took it apart, and sure enough, it shorted. So now when you look at this, you find out at 24.7 feet, it's open because this goes up. So the squirrels, this is all good here. So the squirrels ate the coax at 24.7 feet. So you go out there, you can cut that off and make a splice, put PL259s on in a barrel connector. And now you found it. Also what this told me was, this transmission line right here I have in hand, the length of this transmission line, and I have 25 feet written on it, but the actual length of this transmission line, because the velocity factor is 66, and that's what I have this program at, this is 24.7 feet long. That's what it told me. So let's say you have a spool of wire, a spool of coax, half used up, and it's a 500-foot spool, but you don't know how much you use. It looks like it's half gone. Put a connector on one end, run this, and when it gets to the end, which is in the bottom of the spool, you'll have this, and it'll tell you how long that coax is on the spool. So now you know what you have to work with, if you have to buy any more or not. So as you see, it kept going to 43.75 feet. Now, if this was shorted, the signal would keep going. Now, there's nothing there, so it doesn't know, but it wants to read it. But if it was short, it would keep going, and it would tell you have another problem here. Another thing this will do is, if you see a tiny bump here, if you have a PL259 in the middle of this coax, a PL259, according to the last article I read in QST, is about 25 ohms. So what you'll get is a bump. And what you'll see is, let's say I have it at 15 feet. So if you start moving this, as I am now, and you get down to 15 feet, you'll see a real tiny bump here. And that's letting you know it's an impedance bump. So that's another neat thing about time domain reflectometer. You can tell where all your connectors are till you go all the way up to your antenna. So if you have barrel connectors and they're PL259s and they're not 50 ohms, this thing is going to let you know where every one of those connectors are, which is pretty neat. So that's a neat feature. Multi-scan. Let's put the antenna on. Multi-scan. What bands you want to check? Well, that's what it's going to check. But seeing it's a 40-meter beam, well, the SWR is high on all the other ones. But if you had an off-center fed antenna, you'd set these to whatever you want, whatever frequency you want. You can set these to, and then from there, okay, now you can do it because I stopped it. So now you want to reprogram this. Frequency, let's do it 24000. It's nothing, but that's how you reprogram it. And then you run a sweep again, and it's going to tell you. Now, keep in mind, this antenna is not close to being resonant where it's 2.7. That's because the impedance is so high in the antenna, the losses are so bad in the transmission line, it's fooling you into thinking you have a low SWR. And a lot of people do that. They'll look at an SWR meter and say, oh, look, it's 2.5 to 1. It's close to being resonant on 15 meters. No, it's not. The impedance is so high and the losses are so bad, it's giving you a false reading. That's where OSL calibration comes into play. Now you run OSL calibration, you hook the antenna up to your beam, and now you take a reading, and now you're going to see all over the place is very high. So I'm not sure how much we have left that I can show you in here. That's pretty much the basic setup of the analyzer, and it does a really good job. There's more features to it. I'm not going to get into them too much. He'll do. Let's do cable loss. That's one more I can do. Let's see how much loss is in this cable. So let's hook this guy back up, and then I'm going to finish. You want to see other features? There's a lot of other YouTubes. So let's run a plot, open circuit. And we're going to run a plot. There's a lot of YouTube videos on these things, and I'm not going to keep repeating what they already did. So they're going to tell me to put, I think, a short on there in the end. Yeah, and I had to get a short. Let me take that guy out of here, and let me put it on the end. And this is the short. Here we go. Now we'll run that scan, and we'll see what we can come up with. And it's going to tell your losses across the whole frequency range. Okay, so right now, at 115 megahertz, which is where this is, your losses are 2.32 dB. So now let's see where it's 3 dB loss, which means you're losing half your power in the coax. So right now, at 167.9 megahertz, you are losing half of your power. So if you're putting 50 watts into the coax, 25 watts is being eaten up by the coax. Now as we go down, we get down into the HF portion. That's 32. There we go. So at 11.5 megahertz, the losses are only 0.67 dB. That's less than 1 dB loss. So that's not bad. So as long as this coax handles the power, which this will handle about 100 watts at that frequency with no problem, there's no reason you can't use that. It's no big deal. When I set up portable, I use a 25-foot run of this coax, which is what I have in my hand, and I use it on 10, 15, 20, and 40 meters. And if needed, 80. I usually don't use 80 meters portable, but you can use it 80. The losses are low on that frequency. They're not bad at all, so you can use it. So there's a quick demo of the AA230 Zoom. I hope I taught you a little bit about OSL calibration and time domain reflectometer. Both of those are very, very good tools to use. This is so much better than saying, where is the antenna resonant? What's my SWR? I'm done. Let's get on the band. Use this. Take all those readings. Download software called SimSmith. Learn how to use a Smith chart. And the readings you get off of here, and you put into SimSmith, you can build an LC network. I have a 160 meter half sloper, and I build an LC network using this, the AA600 actually, but a tool like this, and SimSmith. I put an LC network at the base of the tower, and at 1840, that antenna is 1-to-1. I don't need a tuner in the shack at all. Hope I helped you out. Hope I gave you a lot of information. 73. Hope to meet you on the band. This is KU3X. Da-da-da-da-da-da.